In this next section, all of the curves are going to be defined parametrically. So we're going to have an equation for x and an equation for y, and they're both going to be in terms of another variable. Normally we use the letter t, but it could also be theta. So I'm going to start with the formula for the volume. We're rotating this region around the x-axis, so the formula is pi integral of y squared dx. And we've got our limits of x equals 0 up to x equals 2. So I'm going to replace y with what it's equal to in terms of t. So we're going to have 1 over 1 plus t all squared, because we've got y squared and we've got dx. Now the problem with this integral at the moment is we've got a mixture of x's and t's. Dx tells us that we want to integrate with respect to x, but we've got a function in terms of t. So perhaps the easiest way of doing this would be to turn it into a dt integral. So turn it into an integral where we want to integrate with respect to t. So this is exactly like if you had a substitution. We want to replace dx with dt. So in order to do that, we're going to look at our x equation. X is t plus t squared. I'm just expanding the bracket. So we can work out what is dx by dt. Differentiate both sides with respect to t, and we'll get 1 plus 2t. So we want to replace dx with something to do with dt. So if we rearrange this to get dx the subject, we can have dx is 1 plus 2t dt. So our integral is going to be that multiplied by 1 plus 2t, and we're integrating with respect to t. And at this point, I'm going to change the limits as well. So we might as well make the integral in terms of t. So we'll change the limits from x limits to t limits. So if we do the top limit, when x equals 2, we know that 2 is equal to t plus t squared. So if we solve this equation, we're going to get t is 1 or t is minus 2. So we've got to work out what is t equal to. Well, actually they've helped us out in this question because we know that t is greater than or equal to 0. If you didn't have that, then you could also work out which value of t gives you this point here, because we know that y is positive. So if you sub in t equals 1 for y into the y equation, you'd get a half. Whereas if you subbed in t equals minus 1, you'd get a negative answer. So we know that at this point, we know that t is equal to 1. So that's our top limit, t equals 1. And then for our bottom limit, when x equals 0, we know that 0 is equal to t plus t squared. And if we solve that, we're going to get t equals 0 or t equals minus 1. And for similar reasons, we're going to choose t equals 0 because t is positive, greater than or equal to 0. So we'll put t equals 0. So now all we've got to do is we've just got to try and integrate this function here. Now, it might not be immediately obvious how to integrate this. Perhaps if we write it as a single fraction, it'll be a bit clearer. So you could probably do this with a substitution if you wanted to. But I've spotted that this looks like a partial fractions question. So let's do it with partial fractions. So we want to write 1 plus 2t over 1 plus t all squared as a over 1 plus t. And because we've got a repeated factor in the denominator, we need another fraction, which is going to be have 1 plus t all squared on the denominator. So if we times through by the denominator, we're going to have 1 plus 2t equals a 1 plus t plus b. And I'm actually going to use the method of comparing coefficients here because it's dead easy in this case. If I expand this bracket, we're going to have a plus at plus b. And just to make it clear, I could write that as a plus b. That's my constant term, and then plus at. So if I compare coefficients, I know that the constant on the left-hand side, which is 1, has to be equal to the constant on the right-hand side. So I know that a plus b equals 1. And I also know that the coefficient of t on the left hand side, which is 2, has to be equal to the coefficient of t on the right hand side, which is a. So I know that a equals 2, and therefore b equals -1. So let's go back to our integral then. So we can replace this fraction with these two partial fractions. So our volume is equal to pi times by the integral from 0 up to 1 of these partial fractions. I'm going to write that as -1 out there. So I'm going to write that as minus +1 on the numerator. But it doesn't matter if you kept the -1 on top there. Okay, and then to integrate this, let's go to square brackets. And hopefully you can see, you can probably do this without a substitution now. If you were to use a substitution, you'd let u be 1 plus t, and then du would be dt. And then, so you'd have integral of 2 over u du, but that's just 2 log u. So this integral is going to be 2 log of 1 plus t, and you definitely don't need to go through this formal process of substitution each time. You can just remind yourself that when you've got a linear substitution like 1 plus t, you end up dividing by the derivative of 1 plus t, and the derivative of 1 plus t was just 1. And then same in this case, I'm going to work out the integral of 1 over 1 plus t squared. Well, we can write that as 1 plus t to the -2. And I'm not going to do the substitution this time because it's a linear substitution. So I'm going to increase the power by 1 on this bracket and then divide by the new power. So divided by -1 is the same as timesing by -1. And then we would have to divide by the derivative of 1 plus t, which is just 1. Now I've got to be really careful here with this minus. Watch how I didn't have a minus in front of this 1. So this minus is going to be there, and I'm subtracting this integral, which is minus that. So I'm actually going to have positive in the middle, plus in the middle. And then I need to sub in the limits of 0 up to 1. So if I sub in the top limit, let's leave the pi on the outside. If we sub in the top limit, we're going to have 2 log 2 and plus a half. And then we need to subtract what we get if we sub in 0. So if we sub in 0 into this first term, you're going to get 0. And here we're going to have 1. So if we simplify this, we're going to have pi multiplied by 2 log 2. A half minus 1 is minus a half.